All right, we'll start off with this code walkthrough through the Ceph manager with just a little bit of background, I suppose. So in general, the manager was created to originally just purely to offload some work from the Ceph monitors, where they were handling a lot of statistics collection from the OSDs and MDSs and other daemons that could cause them to become overloaded in a large cluster. And since all of this kind of information doesn't really need to go through Paxos and doesn't need to be persisted to disk, the manager was created as a stateless diskless service that runs independently and can persist things if it would like into the monitor or Rados. But originally, it was basically designed as a way to handle anything that ran a cluster that required a cluster-wide view that didn't require persistence and could easily be done in Python. So overall, the manager is written in a combination of a C++ core and Python modules. And the core component of it is similar to other Ceph daemons. It uses all the same infrastructure for talking to other servers on the wire, and it connects. This acts like a Ceph client connecting to the monitor and subscribing to some apps to be able to get information about the rest of the cluster. But what makes it more unique is that it became a base not just for handling stats in the cluster, but also for integrating all kinds of things into the cluster itself. So today, it supports many modules from disk prediction to orchestration to internal cluster tasks like balancing PGs and managing long-running operations for RBD or CephFS. So the entry point for the manager daemon in general, if we start looking at the code a little bit, is like for other Ceph daemons in the ceph_manager.cc file. It goes through the typical daemon setup that you'd see in all Ceph daemons, parsing arguments and environment variables, initializing everything as a code environment daemon, figuring out which network addresses to bind to, then going ahead and starting things up. And you'll see that this is creating a manager standby class here. Another property of the manager as it stands today is that it's designed to run in an active standby mode, where a single instance of the manager daemon is the active one, and it communicates with the monitor to continuously send pings to the monitor to let it know that it is still alive. And so that if the active manager stops responding, the monitor will tell one of the other standby managers to become the active manager. But everything starts out in standby mode. Let's take a look at what manager standby looks like. So manager standby essentially has all the infrastructure you need to deal with the rest of the cluster. It has a messenger as a monitor client, an objector for talking to the OSDs and Rados, in addition to a SFS client. So it'll start out with setting things up. Becoming a configuration observer, adding itself as a dispatcher, as well as the objector and SFS client, so that each of these objects can receive messages off the wire and respond to them. And then it will connect, figure out which monitors to talk to, initializing the monitor client, and then subscribe to the manager map so it can tell which manager is supposed to be active. And also subscribe to or be interested in the other keys, the mod map, the OSD map, the MDS map, and the manager map. We also set up some extra infrastructure to receive a callback whenever there's a configuration change. In particular, we're checking for any config keys that are set that have a manager prefix, and we'll handle those within the Python module registry. So any modules that have their own options, they're all stored under the manager prefix in the monitor's config key structure. And modules can essentially register an interest in these config options changing and get notifications when they do. Then we finish initializing the monitor client, initialize the manager client, as well as adding the manager client again as a dispatcher so it can handle messages for talking to other managers. Authenticate to the monitor. And do some other kinds of setup for getting things ready to run. Then we start running our tick function, which will be what the manager continues to come back to. So let's take a look at that. So in standby mode, all the manager does is send a beacon, which sends a message to the monitors saying, I'm still alive. And it also tells the monitor which modules this manager has, as well as any sort of clients it has, which addresses this manager is using, and other sorts of metadata about the manager, like the Ceph version is running, configuration, that sort of thing. And it's sending all of these things to the monitor. And then this will just keep repeating itself by adding an event after the manager tick period, which I believe is 5 seconds by default. To continue doing this in standby mode. This looks a little bit different if you're the active manager. So you can see where we become the active manager by looking at how we handle the manager map. So when the monitor notices that the existing active manager isn't responsive to, it hasn't sent beacons in a long enough period of time, or there hasn't been one before, the monitor will choose a new active manager and go ahead and put that in a new version of the manager map, which all that standbys are subscribed to. When the relevant standby who's chosen as active receives that new map, it'll go ahead and create a new manager instance with this existing setup that was created, like the mon clients, the maps, and the SFFS client, and the objector that are already initialized in standby mode, and start using that new class to handle things. So let's take a look at the active class. So again, this is similar in terms of the infrastructure. It's got all the tools necessary, the clients necessary to talk to different parts of the cluster, the monitors, the OSDs, the FFS. It's also got a registry of all the Python modules, a index of daemon state, which represents the state of the different daemons in the cluster, and then the representation of the overall cluster state, and an instance of daemon server, which is really where a lot of the work gets done by the manager. That's kind of one of the workhorse classes that's handling messages and responding to them. You can see that we have a number of handlers for different sorts of maps. Handle manager digests, file system maps, OSD maps, central log messages, service maps, and mon maps, and manager maps. Those are almost all the kinds of maps that you can have in a Ceph cluster. Those will be subscribed to by the manager here and received from the mons as they get updates. You can see when the manager is becoming active, when it's first getting initialized, it's subscribing to a bunch of these extra maps, in addition to different prefixes in the key value config space for the manager. It does a bunch of initialization, just getting things all set up. Let's talk to the rest of the cluster. It does a little bit of loading of some of its persistent state that has been added over the years. Things like it's storing some of its data in the device, by different devices in the cluster, in the monitor's config keys. I can move most of this into the modules themselves now, so not a lot of it is in the core code like this. And we also are setting up our Python modules and initializing Python at this point. We call into the Python module registry and storing all the active modules, the modules that are enabled. Before we dive more into the modules, though, let's take a look at the Daemon server instance and what that looks like. So that's, you recall, that's one of the key pieces of the active manager. So that's initialized when the active manager is created. And it handles a lot of the message processing and data gathering from the rest of the cluster. It has a number of configuration options around throttling different sorts of messages and amounts of messages it can have coming in off the wire from different sources. And then it's got its own references to the messenger, the mon client, the internal state of the manager, tracking the rest of the cluster, the Python modules, etc. You can see here when we're initializing the Daemon server, it's setting up its own messenger defined to the public IP and address that everything else in the cluster is going to connect to this manager with, and setting up all those throttled options that we have for the different types of services it talks to. And then again, it starts scheduling the tick function to be called, which is a common pattern across daemons. So every 5 seconds or whatever the manager tick period is, it will send a report, and adjust PGs. So one of the things that the manager took responsibility for from the monitor was to keep track of the status of PGs across the cluster, their current state, their base utilization, all those other kinds of stats that OSDs report. So in send report, we're kind of collecting those all together and setting off the current version of that snapshot of the current PG state to the monitor. We're also including a few other pieces in there. The any help checks that manager modules or other services have added, progress events from the progress module, or that may have been added from other modules. And we're including all those in this report we're sending to the monitor, which will be essentially cached at the monitor and used to respond to your standard kind of Ceph CLI commands. So if you ever see a Ceph reporting with PGs in the unknown state, that would usually most often be because the manager wasn't running or wasn't able to send the PG report to the monitor, which is where that information comes from. So it'll go through the whole map of all the PGs in the cluster, update with the new stats from this PG map. This includes things like I/O rates, recovery rates, amount of data that was compressed, all that sort of thing, anything to do with the stats from the OSDs. Then also look at the OSD map and add any extra health checks that we may get from the PG map or the OSD map itself. And then finally, we have a whole bunch of metrics that we look to report to the monitor as well. So these would be things like slow operations or other sorts of health metrics. I think slow ops is the main one. It can be slow ops from the monitor, slow ops from the OSDs, slow ops from the MDS. Almost every service reports slow ops at this point. And adds those to the report and sends it off to the monitors. That's kind of the core of the active manager. It's getting all these statistics off the wire from the OSDs, getting health checks and slow ops reports from all different kinds of services and daemons in the cluster, and summarizing them and reporting them to the monitor at that manager tick period interval every 5 seconds. Secondly, it's doing adjust PGs in the same loop. And this is how Ceph handles large changes in the number of PGs in the cluster. It'll make these happen over time. So when you set pgnum or pgpnum from the command line, internally, this ends up setting values that are called the target pgpnum or target pgnum. And the manager in this function will slowly go through and adjust the actual values to get closer to those targets until they're reached. So it'll take a look at the current OSD map and PG map. It'll go through all the PDs that aren't creating or unknown. It'll take a look at the current kind of ratios of PGs that are in states that we probably don't want to do anything with, things that are like PGs that are inactive or under recovery for some reason. or don't have anything reported about them. They're unknown. You don't want to make too many changes to a cluster at once. So we'll kind of go through each pool, look at its page number, and if it's not equal to the where it should be, the target, we'll increase or decrease the PGs accordingly at a small interval at a time. I think for the increasing of PGs, it has some sort of limit around here in terms of not increasing it by too many at once, and for decreasing PGs, it only decreases a single PG at a time. Since when you're merging PGs, it's a much slower process since you need to first move that PG, two PGs that are going to be merged together onto the same OSD, and then do them that merge. So in general, if you want to change how the PG behavior in terms of how the number of PGs is changed in Ceph, this is where you would do it. We do have similar logic for PGPnum here, which is the PGnum is the logical number of PGs, and PGPnum is the PG placement number, the number that are actually used for placing PGs. So if you could have, let's say, 1,000 PGs, but with a PGPnum or of one, a placement of one, that means they're all placed together in the same OSD, in the same set of OSDs. So when you're changing both these values, you're trying to get the target to the target PG and PGPnum, and for them both being equal. And the manager does this by sending commands to the monitor, setting the PGnum actual and PGPnum actual values according to how it wants to adjust those. So that's a bit about what the core functionality of the manager does. Any questions so far?
No questions, but that was a good overview.
All right, thanks, Laura. Continue then on to how look a little bit at the modules and how the core of the manager communicates with them, and the modules interact with it. So the starting point here would probably be the Python module registry, PyModule registry. As the comment says, this class is a registry of modules. It doesn't do everything. It's purely about setting up the environment for the modules to run, like the Python thread, the main thread for the Python interpreter. So in general, the way that the manager uses Python is a little bit unusual. It's using the CPython interpreter, but it's using it with separate interpreters, so that each module runs in its own main thread and doesn't have to any kind of crossover with other interpreters for other modules, which means that they don't share any state, but that means they also can't have bugs that affect each other's interpreters or clashes with global variable names or that sort of thing, global state in general. So Python modules are just loaded off of the disk essentially. So whenever you restart the manager, it'll look at the Python module directory for the manager and grab all the Python modules there, try to load them from the manager module path. Let's look a little bit at what the Python module base class looks like. We have a few different properties about manager modules here, whether they're enabled or not, whether they're always on. Always on means that this module is always enabled. It can't be disabled. This was added basically to deal with upgrades and to make sure that there were certain, if there were certain dependencies that always needed to be there, you turn those on unconditionally. We have a few kind of startup things. Is the module loaded, and has it been initialized enough that it can actually run those points or not? And has it thrown any exceptions? See, modules generally have two broad categories of things that are very generally associated with them. First is a list of commands they respond to that they implement, and the second is a list of options. And they've also got, again, their own thread state, which represents the state of their Python subinterpreter, and reference to their Python class. So let's take a look at how a module is initialized. So remember, we're setting up a Python object here, so we're going to use a lot of Python classes to represent objects and methods and the class object itself. The overall module will be created by PyModule create, passing in this Ceph module definition as a pretty generic thing, which is filled with empty things to start with. Then we'll add in a bunch of other base classes to initialize into the interpreter as we need them. You'll see a lot of these PyPrefix functions and types. These are generally part of the Python interpreter itself, or CPython. This is just setting up all the generic kind of base module and base object classes for Python before the module actually gets started and has a chance for its own code to run yet. When we go and actually try to load the module, that's when we set up everything to actually run. So we have our thread state. We create a new interpreter with our own global interpreter lock. This is again a sub-interpreter. And we set up some generic pieces to have the right paths so we can find the other modules that might be dependencies. And then finally load the actual module itself, telling Python there's a subclass of the generic engine module. We load the commands and the options from the module. So these commands and options are all defined in Python. So we're going to be using a lot of these Python methods to kind of walk through Python data structures and extract the information in the C++ code. So in particular, we're going to look at the register commands attribute of the module, and the commands attribute, which will be defined as a dictionary. We'll interpret the command itself as a string. I'll have a description. I'll have a string of permissions it requires. And it'll have an option whether it is a polling command or not. This means whether, if I recall correctly, whether it has to be synchronously polled. I can't remember the exact implementation here. But in general, we're looking at the general pieces of a command. Let's take a look at what this looks like in an example. So all the manager modules are under pipeline manager. You can see the generic interface, the Ceph module.pyi. These are the base classes that we referred to previously when we were setting up the module. This is just the interface, not the implementation. And you can see we have some of these with typing defined. All these starting with underscore generally are used by the internals of the manager, not by the modules themselves. So let's look at an example. Say the crash module. Okay, so this isn't a good example for commands, so it doesn't have commands, but it does have a few options which follow a similar pattern. So options will be defined as an array or a list of options with a number of attributes. And you can see this is similar to the commands for walking through this list of options. And each option ends up being a dictionary with these attributes passed in. So a name, a type, a default value, a description, optionally a long description. It can have minimums or maximums similar to general Ceph options. Basically, all the general Ceph option flags you would see apply to these manager module options too. And we're just populating all these options into the C++ code that's tracking them so that they can be changed and set and gotten through the standard Ceph CLI APIs for config get and set with the manager prefix. So going back to where we were initializing the module, after loading the commands and the options, we've successfully imported it. We've gotten everything set up. Then we're not quite sure. We haven't fully initialized it yet, though. We haven't run its constructor, or sorry, we haven't run its constructor. We haven't run its all of its initialization necessarily. There's also an option to have a standby class where you can have a version of the manager of the module that runs in standby mode and a version that doesn't, that runs in active mode, and those have separate behavior. I don't believe this is used by very many modules, but the idea is there. So here we call the canRun method on the module to determine whether it can run yet or not. And we end up assuming that it can run. And the module is all set up and ready to go. Um, the next piece is probably to look at in more detail what else is part of the module running environment. So active PyModule is the base class for handling things for a module that is enabled and is running. They'll include things like constructing the actual class. It'll have methods that you'll see within the Python modules, and implementing things like notifying the module about different types of updates, whether those are from different types of maps or configuration changes. There's also a separate general method that's used for the central log or C log and notify modules about changes there. So in each of these cases, it's calling into the module by using Python interpreter methods like PyObjects call method on the P class instance, which is the module itself, and it's calling the notify method. But I believe this is arguments of the string type. I don't remember what the end means. With the clog argument being set to the value of a pylog entry. I guess another thing to mention here is the PyFormatter. This is commonly used across the manager code to construct Python versions of objects. So similar to how we have a JSON formatter or an XML formatter for dumping objects, we also have a Python version that has things as lists and dictionaries, Python native types essentially, that the manager modules can interact with directly. So we also have an implementation for calling into methods of other modules. This is called running a remote method. This can be used by a few modules, for example, to create progress events, which are handled by the progress module, and other kinds of intermodule communication, which isn't super common, but this is where that's where it's built. Essentially, you from one module you pass a string of the method name to call and the arguments, and so here we're going to be calling into this the method that you specified with the args and keyword arguments that you passed in. Here's how we're passing commands to a module. So we've gotten a command. This would be called from the main core of the manager part. After it's identified which module the command is for, it'll call into here. And we'll go ahead and look up in the command map, type out exactly what type we need. Get the input, which is treated as a roster stream of bytes or string here, and call into the handle command method, which is part of the generic module base class, I believe. So the basic module base class is implemented within C++. There are a few of these Python classes that are implemented purely in C++ here. There are a few different levels of abstraction here, so it can be a little bit confusing, but generally these methods will be called from within manager modules, and this base manager module has references to the rest of the components of the manager as needed, like the Python modules and other pieces to be able to get at the rest of the system. But in this case, so handle command is implemented in the Python manager module.py. So this is the base package that all modules have access to, and it includes a lot of different kinds of utility commands and methods to deal with different aspects of the system. There are things around handling OSDmap, which you can see is inheriting from Ceph module.base pi OSDmap, which is the C++ base class. And this is a kind of Python wrapper around that. Similar things will exist for the incremental OSD maps and crush maps. We have a general command for describing CLI commands in Python. These are the same kind of properties that you see it's all expressed in the C++ version earlier. This is the Python interface to that. And this is also where we have the other generic types like options and commands defined. So you can see option is really just a dictionary with specific types in mind, or specific keys in mind. But you can see this is the base class from which all modules inherit. So this is the Python version that inherits from the C++ base manager module, as well as the manager module logging mixin. and includes all kinds of things that are accessible from any manager module. So let's go back to the example of we're handling a command here, calling _handle command. We're passing it in a string, and the command is we've just looked it up from the command map, and it's a dictionary of a string to a description of the command essentially. So we look up if the prefix isn't in existing CLI, we'll call into our modules method handle command. So you can actually have commands that aren't described in the commands data structure. But if it is there, then we'll go ahead and call it directly from that commands dictionary that we've loaded from the module itself. See, we don't have a ton of time left today, so I want to try to get back to perhaps any other important areas we haven't covered yet. Any areas that folks are interested in particular?
You covered base manager modules, but I think I don't think you covered active Pi modules with an S on the end, different from active Pi module. That's where a lot of the actual implementations of the functions that are seen in the Ceph module or in the Python manager module are located.
Yeah, that's a good idea, Laura. Let's look at their active Pi modules. Yeah, so you can see this has a number of methods that are used by a lot of different sorts of modules, like getting and setting things in the monitor store, um, getting information about fig options, getting and setting the health checks, progress module events, handling commands, etc. So let's look at example of one of these pieces. Let's say getting health checks. I guess it's also important to note what data structures this active Pi modules has. But essentially, this has a map of all the existing modules, um, their name mapping to their object that's implementing them. Has the local config map from the config key store, the cluster state references to the on client, all the other pieces you need to talk to the cluster, Daemon server, registry Python modules, and this is where the progress events are kept internally within the manager as well. So this is essentially what the manager uses to handle all sorts of things, because this class handles tracking which modules are which, and calling into them to handle whatever needs to be handled. So for get health checks, we're just getting all the checks from all the modules. So we're just going to loop through them all and call the get health checks method on each individual one, which will accumulate the checks to this health check map T structure. Similarly for handle commands, this is where we're calling into the function that we were just looking at. We're looking for the module that the command is directed towards. If it exists, then we'll go ahead and call it its own handle command method. Another aspect is the performance counters. So the manager, in addition to collecting things from the OSDs like the PG stats, it's also getting performance counters from all the daemons, and it's collecting all of the ones that are at priority useful or higher. I believe these are actually collected in Daemon server itself, but they're exposed to the Python modules through active PyModules here. And using an example of using the Python formatter. So we're kind of going through the structure of the counters and adding information about each of them and their values. This is using the standard kind of formatter operations you see in the rest of Ceph, but the sense of creating a Python dictionary and lists and strings rather than JSON or XML. Yeah, perhaps it would be helpful to look at an example of a module as well. So going back to the crash module, for example. So generally the entry point to the module after it's initialized, so let's first run initialization when it's first created. But the main entry point is the serve method, which will run in a loop, generally with a condition like this while it's supposed to be running, do what it needs to do. And in this case, it'll wait for a certain interval before running again. There's a good amount in documentation around generic manager modules and how manager modules are implemented, so we won't have to go into a ton of detail today. But a few other important pieces here would be things like handling commands. So we have some, you can see we have this decorator CLI read command, which is defining new commands that's implemented by this method. So there's a little bit less boilerplate to define them. And let's see, there's a good example. I guess another thing, a common piece you'll see among modules is a self-test method, which is run by the test functions to just verify that things are working as expected in general in a real environment where the manager is fully set up and running. So I think that's about all the time we have for today. I think there's a lot more to cover as well, so hopefully we can get Sage in the future to come back and give us a bit more detail on different aspects of this. But hopefully this gives you an idea of how the core parts of the manager work to some degree. And yeah, feel free to follow up with questions, or if there are any areas that you want to see in the future, let us know. Any questions right
Thanks,
now?
Josh. No, thanks, Josh. That was a great overview, I have to say.
No problem. All right. Thanks, everybody. I'll see you for a future manager walkthrough in the future at a later point in time to be determined. Thanks, everyone.
Thanks, Josh. That was
Bye.
excellent.
Thanks,
Thank you.
Josh.